This is one of the probably 3 video segments that I'm going to prepare for making design tables. Now, if you go to my channel, you see that there are some examples there where design tables have been created, but my approach, and these are kind of the older clips that were made. My approach in those years was to use the parameters, introduce formulas, and then create my design table. Since last year, I've decided to do this in a slightly different way, which is more straightforward. And this is the approach that I'm going to take for the 3 segments that I'm going to make. And this is the first one, which is very easy. I did this problem in class where I actually created a block with a hole, and I renamed the dimension so that I can go to the knowledge toolbar, f of x toolbar or icon, and from there change the dimensions. So that's exactly the approach that I'm going to take in this problem. In other words, I don't introduce parameters, but I will rename dimensions, and based on that, I'll make a design table. All right. Now, the only additional thing here is that in the class when I did this, I did not worry about the part name and material, but in the case of the design table, I'll make sure that these are incorporated. You see what I mean? Okay, so let's go ahead and get into the Catia program. Here is the part design, and my suggestion was, if you're doing design table for parts, start with the part file to work the problem. Okay, so on a convenient plane, on that vertical plane, I will sketch, let's see now, a rectangle. And incidentally, just like I did in class, on purpose, I'm not going to make this nice and centered at the origin. You'll see why, okay? And then a circle here. And once again, just like I did in class, on purpose, I'm not going to make the circle exactly halfway between the center of the rectangle. So I want to remind you how we did this thing in the lecture. Left edge, control right edge, control the middle point. Click on this constraint using definition with the dialog box, and then make it equidistant. And the top line, control bottom line, control the center of the circle. Let's try it again. Top line, control bottom line, control the center of the circle. You make it equidistant again. This is just on purpose because this dialog box is extremely important. You're going to be using it a lot in your course, so it's better get used to it. All right, so let me put some dimension, and these dimensions are the ones that we are going to rename and eventually put it in our dialog in our design table. And also dimension the circle, radius of a circle. It doesn't matter. The calculation is done in terms of radius within Catia, but you can switch between radius and diameter for visual purposes. Okay, good. Now exit and pad it. Okay. All right, good. Okay, now because we're going to be because in our design table we're going to have material properties changing, let us apply some dummy material here. So let me see now, where's the apply material icon? Is right there. You click on it, some dummy material. So for example, aluminum on that part, and we say okay. Do not forget to save these things on the test. If it crashes, you're going to lose everything. So file, save management, save as. On the desktop, you create a new folder. You call it problem 1. And this part is going to go into that folder. Remember, on the test, you're going to have a folder in your Y drive under your name, and you have to organize your work and put your problems, the 3, 4 problems, 4 or 5 problems, I don't know, in an organized way in that folder. So this is what I'm trying to make sure that you practice from, right now. Okay, so the next step is to rename these dimensions. Let me remind you that you click on f of x, the entire database shows up, and if you click on part, if you click on part, and let me say that show me everything, don't filter it out, show me everything. The entire database associated with this particular part that you created appears here. Notice that when I clicked on the part from the tree or on the screen, these dimensions showed up. Now this thing, I like to call it L. So I selected it from the screen and I highlighted from down there that I'll make it L. Okay, good. Now remember, if you say okay, this f of x box will close. I don't want to close it because there's more things to do. So I say apply. Okay, notice that it changed the name, this weird name, database name to L. Now I select this other dimension, which was here. You see from that side. This, we're going to call it H, I think. I think we call this thing H. Apply. Okay. There are two things that can be picked up from the screen here. One of them is the radius. The other one is the depth of the path. So, for example, if I select this is going to be big R, the radius. And if I select this other little green thingy here, and there's two numbers. One is the first limit. The other one is second limit. You obviously want the first limit right there. Okay. And I'm going to make this thing W. I think I call it W width. Apply. Now, this was everything. Now let me filter this out by strings. Okay, if you filter out the things in the database according to the string specification, one thing that shows up is material, and right now it's aluminum. So I'm going to change the name of this material. I'm going to change it to anything that I want. So I'll say my mat. How about that? My mat. So my mat becomes the name that I give to the material. So it's material incognito as far as the name goes. Okay, good. Apply. Notice that it changed this to my mat. Then is the part number. Part number is the part name. So I select it, and I'm going to call this thing my part. How about name? It's just the name that I give it. So apply. And we say OK. All right. Good. Save. Where's the save here? Right here. Good. Now, in the knowledge toolbar, right there, first one is f of x. We just used it. In the middle, you see something that looks like a monthly calendar. Actually, this is design table. You click on it. Notice that there's two radio buttons that are present here. One is to create a design table from a pre-existing file, and that is not the case. In the older video clips that you may see, I might have created the Excel spreadsheet, put it in there, but we're not going that route. Create a design table with current parameter values. This is what I want. You select this radio button. I'll leave it as default vertical. So it says, okay, you've got a bunch of things in your database. Which one of them do you actually want to send into the Excel spreadsheet that you're going to be creating? Well, let's start with the renamed stuff that I've made. All of these, I'm going to send that into the Excel spreadsheet. And the order that you pick these is going to be the order that the columns of the spreadsheet are going to look like. Now, of course, you can do this in any order that you want, and you can change that order, but I suggest that we go and do it in an organized way right now. So, part number, this goes as the first column of the Excel spreadsheet, then material, second, then we go, for example, to length, and the height, and the radius, and the width, and we say, okay. All right. It says, all right, you're going to create an Excel spreadsheet Where do you want to put it? Now, I'm going to put it in the same folder where my part is stored. Remember, on the exam, on the test, when you give us your part, you must also give us the design table, the Excel spreadsheet. It must be in that folder, otherwise we will not be able to mark your paper. Okay, so you can give it any name that you want. I'll call it design table 1, fine. Default name. Okay, just give it a second. This step takes a bit of time. I don't know, ordinarily not that long, but anyway, we'll see. Oh, there we are. Okay, look at what happened. It created a table for us, and this table has several columns. First of all, column 1 is the different things, different number of things in it, which is only 1. Column 2 is part name. Currently is part 1, so it says part 1. And then this column is my map, and the default material was aluminum. And then there is L, H, R, and W based on the existing values. Okay, now if I want to add more things, because these are the default stuff, it may not be the actual dimension that I'm interested in, you say edit table. And here's your Excel spreadsheet. Let's expand this thing so that we can see things better. There is the first column, which is part name. There is the second column, material. Third column, length, height, radius, and width. Now, these are the current values that I have in my model when I made it. Now, we can always add more stuff here. If you don't want this, you can actually delete it. But let's go to add some more stuff here. So, part name or part serial number, A001. Material, let's say it's iron. Remember, it has to be uppercase I. This material have to start with uppercase. Otherwise, Catia will not know what it is. Okay. Length, make it 9. Height, make it 4. Radius, say 0.5. And the length, okay, this is the width, the padded width. So make it 3. Let's do another one. A002. Material, steel. Big S, T-E-E-L. Say the length is 1. The height is also 1. The radius is 0.1. Now remember, if you put a reasonable number here, for example, if you put radius equal to, I don't know, maybe 0.5 or 1, it may be self-intersecting, or maybe the radius becomes bigger than the rectangle. So be aware of the fact that if you put just random numbers here, things may fall apart, and then you have to go fix it. And the width, let's make it very thin, 0.1. Let's do another one. Serial number CWWD. Okay, that's the name of the part. Okay. I don't know, maybe brass. And let's say length of 3, radius of 2, height of 2, radius of 0.5, and width of 1. Now, if you don't want the first one, the one with the nominal dimensions that you made, the dimension that we can delete it, but I'll leave it here. Okay, so you save it. Remember, you have to save this, and you have to close it. Otherwise, you can't proceed. Now, when you save and close this, you get a update message. You'll see that in a second. It reminds you that you have updated the design table, and just acknowledge the fact that yes, and this is the stuff that I inputted. Now, look at what happens. The first row is the nominal one. Okay, the name was nominal part 1, and the material was aluminum, dummy aluminum. If you go to the second row and apply, assuming there were no mistakes, notice that the serial number changed to A001, or part name changed to A001, materials iron, and the dimensions are exactly what you put in the table. You click on the next one, apply, you get the new part name, the new material, and there is the new dimensions. This is amazing. This is great. Apply, and there we are. Now you can always go to edit table if you want. The Excel spreadsheet opens up, and you can add stuff here. For example, let me add another row. Okay, so how about R4 is the new part name. Material is let's make it bronze. Okay, length is 1, height is 1, radius is on purpose. I'm going to make radius 3 because I want to show you what happens, and the width, I don't know, 0.5. That doesn't matter. I want to show you what happens here. And in fact, let's do another one. R5. Let's make it also out of bronze. Okay, 1, and again 1. This time I'm going to put a radius here that make it self-intersecting. So maybe how about 0.75. This last one is not going to work, but we're going to see that 0.5. Okay, save it, close it, wait for the message, update message. All of these are here. Everything else, everything is okay. Before that, we already tried it. This last one, this fifth one that I added is also going to be okay. No problem. Except that the radius was so big that actually the rectangle ended up to be inside of it. So, okay, this is not what we wanted, but it could happen. Now, if you go to the last one, that's going to be problematic. You see that apply. Whoops. Okay, it's on the verge of being problematic. Okay, so let me actually go ahead and do the following. Let me change this thing a little bit bigger, make the radius a little smaller actually, maybe 0.45. Yeah, 0.45, something like that. Edit table. Okay, let me take this 0.75, make it to 0.5. Maybe 0.6. This is going to cause a problem. Save and close. Wait for the message. This last one is going to cause a problem. You can see why. Now, if you want to know what happened, actually, you go to the sketch, double click on it, and this is what happened. So how do we fix this thing? Well, the only way you can fix it is either undo a few times and go and fix your table, or you should be able to see your table in the tree, because if you don't see this thing, you can't get to it. So if you see it right now, and I've told people how to activate the parameters. I don't have any parameters, okay, except for that material, I suppose. How to activate these in class, and it's also on my other video segment. Go look at it. Okay, so here's we go. Here's the we go to this table, design table. Go to the Excel spreadsheet, and there's the 0.6. Let's make this thing 0.4, and save it, and close it. This last one that was not working before will be working now. All right. So this is going to be the first of the 3 segments that I'm going to make. The other 2 is the same process, except that the shape is more complicated. Okay. Now, if you go to the older video segments for design table, you may see it. You may see that it's done differently. In other words, I create parameters. L, H, W, I don't know, R, whatever, and those are not renaming of dimension. The parameters are created, and then I select those dimensions from the screen, and I say it's equal to, for example, L. This is an equation. You create a bunch of equations. And then the other steps are also a little bit different, but you can do it based on renaming, as you see here. Okay,